Welcome everyone. Welcome to Bonquisitive Day, another episode of Bonquisitive Day. Today we are going to discuss about something which has taken the whole world by its tail. So it has basically created a storm, and we will talk about it because there are a lot of buzz around it, a lot of false information going around. We'll try to probably navigate through that, but since this is the tech channel, so my main focus would be to actually talk about the technical details rather than the political or geopolitical implications. But probably some of it might come. As you can see from the screen itself and from the title probably, so we are going to actually talk about two models, two sets of models. I wouldn't say two models, two sets of models that have come very recently in the recent weeks, and which have basically just created a havoc change in the whole AI community, whole AI space. I'm talking about obviously DeepSeek V3 and DeepSeek R1. So DeepSeek is basically a Chinese company, a Chinese research company who has been in AI space for around 2 years. So they are working on AI models from 2023 as far as reports goes, and not only that, they have already worked on distilling a lot of open sourced models like Llama. And what do I mean by distilling? So, if you are from AI space, you will know that usually every model is associated with some amount of model weights, right? And the number of parameters in that model weights or the size of the model is basically the number of parameters that you need to train. And the bigger the number is, the bigger the model becomes. Obviously, there has been kind of a consensus that to get more complex models, you need bigger and bigger models. So basically, more parameters, more trainable parameters to get it to do some complex tasks. And this has been the scenario, and the big tech, I mean Google, Microsoft, through OpenAI and Anthropic, all the big players, they have been working on obviously the architecture side of things as well, but they have been working for a long time on making bigger and bigger models. But at the same time, if you know, last year Meta, which was previously Facebook, they open sourced a few models, Llama family models. Llama 3 was introduced. Right now, there is Llama 3.3 that has come up. Anyway, that is a side discussion. But now, say for example, Llama 3 is of certain size. Let's say it has 200 billion parameters. Just for an example, you can just search how many parameters a certain Llama model has. But say it's 200 billion models. Now, obviously, it kind of also has some kind of benchmark in terms of its performances. The theory about distillation is whether you can still have the same performance but having a lower number of parameters present in the model. So this is post-processing fine-tuning that people do, and this is where actually, if you will believe it or not, but this is where DeepSeek actually started. So before all this drama, they were actually working on distillation, model distillation, and they were working on improving the models in terms of how you can compress the model size yet get the similar kind of performance that we were seeing. And for a long amount of time, the closed source models were winning. We will come to all these parts later on. What closed source means, what open source means, what is the difference between free to use versus open source. All these things we will try to cover in this video. So stay on tight. This will be a long, detail oriented video, but then this will be very technically focused as well. So it would be very good if you have at least some idea of how AI models work, because there might be a lot of technical details that I will talk about. But I will try to again distill the knowledge as much as possible, so that even if you are from a technical background but probably not apart from AI, ML, you still at least understand what all the buzz about. Okay, so there, as I say, so there are two models, the two family of models that we'll talk about: DeepSeek V3 and DeepSeek R1. So we will basically cover the technicalities, what are the technical points that kind of sets them apart. Like, what is so special about this model? So we will talk about the technicalities. We will talk about the buzz, like why exactly people are so excited about it, and not only excitation. So there has been a lot of backfires as well. So we will try to cover some of the metrics, and then at the end, I want to also cover a little bit about what it actually means for you. How a common user, irrespective of different spaces, and we might actually cover for different sectors as well. How does it actually matter, or what would be the long-term consequences? So I'll try to talk about that. Okay, so let's start from the technicalities. I have the DeepSeek V3 paper open with me actually, and this is one of the great things about DeepSeek, by the way, was it has basically published a bunch of papers, which again are all on archive. So if you are from computer science background, you know a lot of people, not only for computer science, it could be like for any STEM subjects. People put their papers on archive, and you can just go to archive.org and you can visit the papers. You can just search for DeepSeek V3 papers and you can get them. Okay, so I'll not go details by details, but let's talk about DeepSeek V3. Uh, okay, what what exactly DeepSeek V3 does that is different? So I don't want to get into a lot of details of how LLMs work. So if you want to understand how LLMs work, you need to understand a little bit about transformer architecture, which is core to all the LLMs or large language models that people talk about. And once you actually get to understand transformer, you would also understand attention, how attention works. So attention is nothing but, say for example, you have a large input and you want your model to kind of only attend to certain parts of the sentence. So this is what attention is all about. It's just putting some weightage to certain parts or sections of your input, and how exactly attention is different in this case, in this DeepSeek 3, the model that we were talking about. So it kind of introduces a few properties. Let me try to write them down. Okay. So one of the things that it talks about is multi-head letting attention. What is multi-head latent attention? So as I said, attention is basically, you can think of it as providing weightage to certain sections of the input sentence that is basically being inputted. Now, how does it matter? Why it should matter is when you kind of see already where to put the importance, your model obviously understand like, okay, these are the important parts of the sentence and it keeps it in the memory. And this is why when it tries to predict some output, it understand what are the important parts of that sentence was. So in any LLM architecture, in any transformer based architecture, attention plays a very big role. You can actually train an attention network from scratch, just a very simple one. uh, but the core idea is once the model once the model knows like where to put importance, what are the important bits and pieces of a particular sentence is, it understands what to output as well. What sort of thing is relevant. So usually most of the in most of cases LLMs predict token by token. even then it needs to understand what is important and what is not, so that it can output properly. So that's why attention is very important. But uh, the way DeepSeek V3, the way the research team has implemented DeepSeek V3, it's not normal attention. As you can see, it's multi-head latent attention. So multi-head attention is nothing but, you can think of it like having multiple eyes instead of one eye, having multiple eyes to look into the input and trying to understand how exactly or what are the important parts simultaneously. So multi-head attention is an improved version of attention where you significantly reduce the time and basically make it more efficient, make the models more efficient. And multi-rate latent attention is again kind of another variant where not only you are trying to look simultaneously into the input, but also you are caching some key value pairs of like the important bits and pieces are basically stored efficiently in a key value format pair. And what exactly the key value format pair would be, it also depends on the training. So what it does, it's actually help the whole inference part of the system way more efficient. So what is so we all know like the training part is when you basically have the whole data being trained, the LLM is being trained on the whole data and all. So it's a very long process, right? But usually what we care about is the inference part. When we are using the model as it is, we are providing some input and the model is outputting something. During that inference, multi-head latent attention and specifically the way the DeepSeek guys have implemented it, it actually reduces the time, basically the latency of prediction, and not only that, it also takes much lower amount of resources. So both from compute resource point of view as well as the time it takes to output the tokens, from both sides, it got reduced a lot. So it's way more efficient than our usual models. So this is one part of DeepSeek V3, which is very unique per se. Then it's also a MOE model. What is MOE? Let me also write MOE. Usually we write O as small. Uh, so MOE is stands for mixture of experts. Okay, so it is also called mixture of experts. What exactly it is? So the idea is if you have a very large network, so it kind of becomes a generalist. Instead of a generalist, you want multiple experts to work on your input or on your data. So now a lot of people, what they do is, say for example, you have like a 200 billion parameter model. Instead of a single network, they kind of build or they kind of divide the whole network into smaller subsets. Each subset is trained in a way so that like each subset kind of works independently as an expert. It could be an expert on a given topic. And the great thing about MOA is not only it kind of fine grain the expertise on different topics, but when we are actually doing the inference, as I talked in the previous case, the inference is the main thing when we are actually using the model. During inference, there is kind of a router which decides based on the input which expert should be assigned this particular work. And obviously, for that reason, that particular it could be one or it could be multiple, but only those experts those are relevant. Only they in those part of the networks only the data is passed through. That means when you are doing the inference, the whole network is not being activated. Only a portion of the network is being activated. This is a huge thing because if the whole network is activated, not only it will take more time to basically have the output, Rather, you would also get a large amount of time to basically do that. So both time and compute. Again, these are the golden things that you should always look for. Whether you could have the time reduce, the latency, like the amount of time it takes to kind of predict the output, and also the compute, how much computation is happening. Because if you can reduce the computation by a lot. Think about it. You can even run it on local machines or your mobile even. There are some use cases where people have started using LLMs in their mobiles just by doing a lot of optimization in terms of computing. So anyway, so MOE is great in that sense. It kind of creates or it divides the model into multiple experts, and this is why. And if you see the DeepSeek V3 paper, so let me bring the paper over here as well. Yeah, so if you just see the technical report of the paper here, it is a 671 billion parameter model. So it is a 671 billion parameter. So this is a lot actually. You can think like if all the weights are in say FP32, that is floating point values of 32 bits, you can compute like exactly how much space it would take, but only 37 billion activated for each token. That means like whenever any token is basically being generated, only this amount of the network is being activated. Obviously, now you do not need for storing the model. You might need a lot of space, but actually the inference cost is very less now. The time is very less now. Even you can distill it very much. You can distill it, which they have actually done. So they have distilled the model and gotten tremendous results. So these are the good things about DeepSeek Vici. So again, I'll not talk about the whole paper because that would be way more technical and it would take a lot of time. But I just wanted to highlight a few things. So MOE is not introduced by them, but how they implemented MOE. So this is critical. So MOE, this kind of architecture, the mixture of experts architecture, has been for a while now, probably 1 or 2 years, if I remember correctly. Mixtral, one of the other teams from Europe, they have also like some models in MOE architecture. But the cool thing is they have their own MOE. So they have a DeepSeek MOE, which first of all they have a shared expert as well as like proper expert. Okay, so they have basically done a lot of fine training. So they have, if I remember correctly, there are around 230 odd experts, or basically 230 odd subdivisions of the network, the whole neural network. And then there are shared experts as well. We and for each token, I think 8 experts are being activated. If I remember correctly, you can read the paper. So the novelty here is about how you build the MOE structure, how many parameters are being activated, and obviously you need to make sure that the performance is not getting affected. That is also one of the key thing. Just by reducing for different optimization purposes, if your performance goes down, obviously you won't use that particular model, right? So this is also very important part. Anyway, so MOE, multi-latent attention, there are other stuff as well. You can go through the DeepSeek paper and you would see like there are a lot of other stuff which is remarkable in their own nature. If you want to compare it with closed source, that's where the things becomes very crazy. So DeepSeek V3, though it's open source model, it compares very closely with GPT-4o. So if you are familiar with the OpenAI model, so OpenAI GPT-3, GPT-4, GPT-4o is the one of the latest ones. So in performance-wise, it is almost, or it is very close to GPT-4o, the latest version, and that is the cool thing because It for training purposes, if you just think about the training part, it takes way less amount of time, way less amount of compute resources. For inference, it is very fast. It is very cheap because the cheap part can be attributed to many things, but it is very cheap right now. I'll show you how much it will actually it cost you if you want to basically use the API version of it from DeepSeek themselves. But that is the thing. So one of the major player in AI, which is OpenAI, they have this great model called GPT-4o, which is obviously a closed source model. And now your open source model is almost on par. So this is actually what makes all the buzz around DeepSeek V3 first. So DeepSeek V3 itself is like remarkable in its own nature, right? Now let's kind of move towards this other one, the DeepSeek R1. Okay, so we have been talking about DeepSeek V3, which is kind of a model, a big model, obviously, MOE kind of a model, and obviously the way it has been trained, the training pipeline. I haven't talked about a lot, but even the training pipeline that they have implemented is completely they have basically changed it from the ground up and made a completely novel approach to optimize the whole pipeline and everything. But now comes super reasonable models, super complex models. So DeepSeek V3 is good, but at one point when you basically are working on very complex problems, it could be coding, it could be math, it could be research kind of problem, research problems. So for all these complex tasks, there are a few people in the industry, few groups that are working on a completely separate way of achieving that, and that is through chain of thought (COT), and a model which is very familiar. You might be very familiar with it. Is again from OpenAI. That's called O1. So there was an O1 preview that OpenAI made public, and very recently, just a couple of months ago, in December only, I guess, they kind of made it completely public, the O1. And not only that, it is very, I would say, costly to use O1. So O1 is a very complex reasoning model. And why it's called reasoning model? Because it takes a lot of time. So OpenAI have changed the whole paradigm by putting a lot of effort during inference. So if you see, like for most of these models, it could be DeepSeek V3 or even for GPT-4o and all these models, you spend a good amount of time in training the model, in fine-tuning the model and stuff like that. But then you kind of put it out there for inference. Whereas now they thought like, okay, instead of doing all these things, let us also put some scaling and optimization during the inference time as well. It would increase the inference time, obviously, but it will give me way more. It would be able to generate way more complex answers, or it would be able to solve more complex problems. We are not sure whether that would work or not, but basically that was their thought, and they kind of showed through a lot of benchmark studies and stuff like that that it was performing well, at least performing well from the GPT-4o model or that kind of same kind of models, right? So the reasoning kind of thing works. So the model basically thinks about its response during inference based on user data as well, and it kind of improves its answers. So this kind of optimization also works. Okay, but it as OpenAI kind of put it, like it's costly. But now, what DeepSeek has done and what has kind of revolutionized the whole AI community is that they also build a reasoning model called DeepSeek R1. And DeepSeek R1 is how it is different. If I just want to go technically, it is way more RL focused. So reinforcement learning is obviously a key step in most of the trainings, but it is usually still used as a kind of a fine tuning thing, whereas SFT or supervised fine tuning is the main player while you basically train all these models. So SFT is usually, at least for up until now, SFT has been the key method to improve the performance or improve the training performance of all these models. But what DeepSeek had done is they focused on RL a lot, reinforcement learning, and they kind of observed that if you can, first of all, create good quality data and stuff like that, if you work on the pipeline, and if you have also introduced RL from the ground up, just from the reinforcement learning itself, reasoning can emerge. So instead of actually hard coding the reasoning part during inference, if you can do a lot of reinforcement learning with proper reward system, the reasoning can be emerged as a pattern. And, not only that, again, same things like with the performance is great, literally great. Not only, even apart from that, also they have created some other, uh, I would say, like a first thing or novel thing as well in terms of pipeline, how you need to create your pipeline. Then they have also worked on the cold start problem. So usually RL models or pure RL models, they go through a cold start problem. But what they have done is they use DeepSeek V3, and using DeepSeek V3, they have initially created a model called DeepSeek R1 V3. It's kind of a precursor to R1. And then what have they done is they use this to kind of remove the cold start problem that RL usually has. So they kind of gone from DeepSeek V3 to DeepSeek R1, and they have used there's something called group relative policy optimization, GRPO. So this is an algorithm which basically eliminates the need of a critique model. So usually RL works like you have a set of actions, and after the set of actions you kind of also assume a policy. You have a critique model, you have a reward system, all of that. I won't go into detail of reinforcement learning, but there's a whole set of things that you want to optimize for. But you have to think about, like, the more players are there where you want to optimize, the more complex your problem becomes, the more tedious your whole training procedure becomes. It will cost you more money and stuff like that, right? So it's like it will spiral out. Whereas they have, as I said, they have optimized the complete training pipeline, how to train, how exactly the data flows should be. They have actually divided into multiple stages as well. So the whole training was divided into multiple stages. They have like tweaked their architecture a lot. So obviously the MOE was there, but even with MOE, they have also created like specialized experts. All the stuffs that I was talking for DeepSeek V3 were also there. But then they have like put completely reinforcement learning paradigm there. They have used DRQ, as I said, as a policy optimization, so that they do not need a separate critique model. And then what that does, it's for each token, instead of trying to compute error one by one, it kind of it optimizes rewards based on group comparisons. So it kind of also reduces the computational cost as well. So basically, a lot of things, and the remarkable thing was the performance is great as well, right? So this is what at the end matters. So people tweak or people work a lot on different kind of architecture, uh, training pipeline, training paradigm. But at the end, all it matters is whether the performance is good or not, right? And let me just bring this graph to you, which was also something you can see. Yeah, you can see in the paper. Yeah. So if you go through the R1 paper, so both are open source papers. So you can basically read both of these papers. And if you see this graph, this plot, it is very interesting because uh, it kind of compares with industry leaders in some way. Claude is by Anthropic. Claude 3.5 Sonnet is kind of their base model, base closed source model. So Claude 3.5, this is a closed model. GPT-4o, obviously a closed model. Llama 3.1 is open source, by the way. Llama 3.1 is open source, but I would tell you like some pitfalls of it. Coin is again it's again by a Chinese company. It's also open source. I'm not sure which company, but it's again from a Chinese company. Then DeepSeek V2.5, DeepSeek V3, right? Oh, sorry, this was the R1 paper. Sorry, V3 paper. Sorry. Yeah, I need to see. I need to basically show this thing. DeepSeek R1. This graded lines, blue lines. Then OpenAI O1. O1 is another reasoning model. DeepSeek R1 32. So they have also made a distilled version of it. So DeepSeek R1 is the main model, and there's a 32 billion distilled model, which is again great. And then there's O1 Mini, it's again made by OpenAI, and then DeepSeek V3. And if you see the performance, I don't want to go into details, but the performance is on par. Like you can think of it, okay, in most of the cases, and these are all in benchmark. So when you are using it for your own use cases, you might not even see any difference between O1 and DeepSeek R1. Now, why the buzz? I have already talked about a lot of these points, by the way, but what's the main reason all these people are being crazy about it? The main reason, obviously, is the cost and the performance. So OpenAI in December only, yes, they have introduced the O1 complete family, and for proper usage of O1, now you have to subscribe to a $200 plan. So they have a pro plan and plus plan and stuff, something like that. But you need to basically have a $200 per month plan, and even then, Sam Altman, who is the CEO of OpenAI, he said that they are not making money because people are using it too much and stuff like that. So even for them, $200 was not enough. They might have actually increased the price. We don't know. But now here's a Chinese company that has come up with an open source model with MIT license, with a very permissive license. MIT license, why I'm saying permissive? Because you can tweak the model, you can download all the weights, you can do everything. So there's a difference between free to use and completely open source. So there are a lot of things that are free to use. Even for ChatGPT to up until some point, you can use it freely, right? It could be GPT 3.5 or 3.5 Turbo, or even some portion of GPT 4o that you can use freely. But using it freely doesn't necessarily mean that the model is open source. When we say a model is open source, when the author or the people that have built the model, they have actually given you both the architecture as well as the weights of the model, because the weights of the model is the main thing. If you have the architecture, if you have the weights of the model, you can basically run it on your own machine. You don't need to go to somewhere else like a chat GPT or some other people to kind of build it. So that's the great part. Like you can run it on yourself. You can not only run, but you can do modifications to it. So think about all the players, all the people that have probably some private data or something like that. They want to fine tune these models with their data. They want to probably tweak or make it better. So it's like a the whole open source community. The goal of open source community is make everything, make knowledge open to all, so that with the community intelligence things get better and better. This is how science and every discipline is getting improved, is because all the knowledge are being shared usually. Obviously not everyone is behind this improvement of science and stuff like that. There are a lot of people who are just there to make profits, and for them it's they kind of create patents, so that like any people other than them cannot use it. If they use it, they have to pay some fees and stuff like that. So usually business players, a lot of tech giants, they have kind of created a paywall around it. They have created a barrier so that up until one point you can go with open source things, but to get the best out of something, usually you have to pay stuff. But now there's a model which is open source, completely open source. You can freely use it, and the performance is on par with $200 models. That is incredible. This is why all the buzz. Along with that, it is also said that training cost was very minimal. There has been some values that are being floated around in the social media. It's very hard to kind of understand or kind of validate those numbers because they are not official. So, like 5 million is something that is widely circulating. That the training cost was around $5 million and stuff like that. It might be slightly more. It could be slightly less. It could be like a way more. We do not know, but it is obvious that the training cost is way lesser than what OpenAI had, or even Google, Anthropic, and all these big tech giants had estimated and had been basically talking about. And you have to understand the take economics landscape as well. There are investors who are investing a lot of money because these tech giants are saying like, okay, to bring AGI, the artificial general intelligence, or to basically have the best model or more complex models, we need more money because the training will take this much amount of money, right? Few millions, like 500 million, billions of monies will be required and stuff like that. But again, a company had basically built it in almost one hundredth of its training cost of OpenAI or some other big tech giants. This is remarkable, right? And not only that, I'll also show you that I was if you see the pricing of these models for 1 million input token. So usually whenever you are using an API, you have to pay for both the input that you are sending as well as the output, because those two are combined when they basically estimate the price. If you see, this is way less than what you would probably have to pay for when you are using OpenAI API. Say, for example, if you are using the O1, I think it's almost $7 or something like that for uh, yeah, for 1 million token. Uh, so this is remarkable. This is remarkable. You are getting not only through API, and obviously there's a DeepSeek chat.deepseek.com where you can freely use both of these models. Hugging Face, they have already like integrated it into the Hugging chat, so you can use that there as well. They're also working on basically creating the whole pipeline and kind of uh, revalidate or re-examine whatever you say. They are basically doing that with both of these sets of models. So these are the things. So first of all, the main buzz, and it has been creating a lot of buzz. Like yesterday, I saw like almost $500 billion was wiped out of US stocks market because just of this case. People are basically selling off because now everyone is thinking Nvidia, basically the main chip maker company, they are basically hyping all this stuff about like you will require a lot of chips and a lot of things and a lot of things. So the economy is being affected. The tech world is being affected because now people don't know how the tech giants will react. You have There's one of the biggest companies which have basically put a $200 price tag each month, and not only it's not one time, it's each month to use something, and someone else has just come up and given it for free. So there has been a lot of how would I say revolutionary change that has come up. Obviously, there are setbacks as well. So there are some controversies regarding since it's Chinese. So in the Western world, there are a lot of distrust around Chinese stuff, as you all know. I don't want to go into the geopolitics of it, but I just want to mention a couple of things. One is there has been a lot of chatter about them taking control of your data, them stealing your data and stuff like that. So a lot of the people that are actually doing the talks, they are not aware of how AI models work, or even how software industry work in as a whole. If you are using chat.deepseek.com, basically these models in the DeepSeek's website, they're available free to use, right? If you use that, they're obviously taking all kinds of data from you. It could be like whatever you are typing, and it could be keystroke patterns, it could be other stuff, how much time you're spending and stuff like that. They can actually take a lot of data out of you if you're using their website to use these models. But you have to be if you just hear about this, you would say, oh, how can they do that, how can they take my data, what is about data privacy and stuff. But if you are aware of the industry, if you are aware of the industry practices, literally each and every product is taking data out of you. They usually say a lot of things about data privacy. There are obviously some laws regarding that. EU is the most strict, I would say, bunch of countries, and or they have the most strict guidelines about who can use their users' data, how that needs to be used, when it needs to be deleted, and stuff like that. But let me tell you, most of the US companies, since they are from US, if you think about Google, OpenAI, Microsoft, every big tech giants, Nvidia, everyone is from US. They do not abide by all these rules all the time. Most of the time, Google or Microsoft or OpenAI, they are also taking a lot of data out. So if you just hear it out of context that okay, this Chinese company is taking my data out, it might sound scary, but the reality is all the products, all the tech products, all the websites, most of the websites actually take a lot of data out of you to create their own analytics. They want to understand which kind of people are basically visiting their website. They also need to understand your keystroke pattern just to understand whether you are a bot or you are a real person. Similarly, they also take data about your location. They also take data about some other stuff just to understand their user persona. They want to understand which kind of user is using their product. So all the websites, all the products that you use digitally, most of them actually take your data. If you are not in EU, so even in EU, if you are in EU regions, even then, if you are using some product, you might have probably just ticked off some terms and conditions where a lot of these things were written. So in most cases, these claims are, I would say, very true. The motivation behind these claims can be debated, but I don't want to go towards that. But there's a way to look at it. Like it's not only a Chinese application that is doing it, first of all. Okay. This was like a big debate portion that I saw on LinkedIn. Like a lot of people talking about it. The other portion is the good thing is DeepSeek team had made it completely open source. Like you can actually download the model and you can run it on your local machine. If you are running this on your local machine, obviously there's no point of any data leaving out of your machine. So basically, all the ideas about someone stealing your data would be nullified if you just use it in your own machine. Now, some people can argue that okay, most of the people doesn't have the system, doesn't have the compute power to kind of run this kind of models. Here's the thing. Now they have also created a distilled version, 32 billion, as you have seen. The 32 billion version is smaller, way smaller, that it can run on a lot of machines. And if you're not a serious AI programmer or AI enthusiast, are you even bothered by the data privacy things? There are a lot of questions. You might be bothered if you are in industry, if you are an enterprise, you are bothered because enterprise people, organizations, they work with a lot of data that they do not want to share, but then they have the provision to create their own server and host the models there. Because it is open source, they can do that. They can't do that with OpenAI. To use OpenAI, they have to pay for the API. So basically, you are basically using a black box when you are using closed source models. You do not know how exactly the tokens are being generated and stuff like that. So there's you do not have any context. You just understand. Okay, if I send the input in this way, if I send a request this way the response would come. And based on that, you basically create an application or create whatever use case you want to. But now, for with an permissive open source license, you can have it installed on your. You can tweak it, you can fine tune it, and then install it in your own server, so that you can host it. You can do whatever you want with it. So it's not black box anymore. You know what you are using. You know what kind of things that can happen to it. You can make changes to it. That's the biggest thing. So I hope I was able to at least articulate some of the points of why it made a lot of buzz and what it actually meant. Basically, navigating through all the buzz, what it actually meant, and what it can mean for you. The last point, I have already like talked about most of the things up until this point, right? So it's not like I haven't touched this point, but if you are a user, if you are a normal user, most of the times even benchmarks doesn't do justice because your use case might not require this much of a complex model. That's the first bit. As a normal user, you might actually find R1, O1, all up to the task of whatever you want to do. Firstly, now for an average person trying to pay $200 may or may not be feasible. You might be rich enough that $200 doesn't mean anything for you per month, or you could be like, oh no, I can't actually pay $200, 200 USD per month from my pocket just to have some assistance on some problem thinking or some complex things. And if that's the case, obviously R1 is a good choice. Now, are you that kind of a user who is a lot bothered by this data privacy thing? You might be. You might be working on something sensitive. You might not want that data to be shared. But then you also have to think about whether you are working with that particular data on other products as well or not, like OpenAI or other stuff. Because once you are basically sending the data to OpenAI or Google or whoever the end people are, you do not know what they are doing with your data. Many might say like, okay, we are not doing anything, we are not storing your data, but there has been a lot of leaks, lot of reports that has come out. There are a lot of cases that has been filed, a lot of lawsuits, which kind of says otherwise, right? So we do not know whether people are using our data or not, in what way they are using, what way things are being collected from us, user behavior, user data are being collected by us. So if you are bothered by data privacy thing, you shouldn't probably use any of these brand methods. You probably have to buy a lot of compute, you have to build a good system, and probably then use one of the open source models. You can use it locally, because if you are using locally, then there's no concern of privacy. But again, if you are a normal user who doesn't bother that much about privacy, obviously apart from certain SPIIs, especially sensitive personal information or some identifiable information, you shouldn't put that in there. You shouldn't put your credit card number in any of these applications. That's plain and simple. So what it can mean for you? It's a great thing. It's a great thing in terms of if you are living in an era where you are using AI a lot, like myself, I develop a lot of things using AI. I work on AI and I do a lot of research as well, research work. For all those works, it actually makes sense to use R1 because now you have a model that you can freely use, that you can tinker with, and you can get very good results. So for most of the people, it actually means very well. It's also is very well for the open source community because the open source community has now something which even the closed source people, closed source tech giants, they thought it impossible. Right, so a lot of things this has made a lot of people excited because of a lot of issues. Obviously, there are some concerns, probably some valid concerns. I won't say like all the concerns that are there are invalid. There are some bias that people have seen while using it. Like since it's a Chinese application or an model that was built in China, so there are a few topics that were like that have some biased answers. So that's obviously there's some bias in training data. A lot of people are making a lot of fuss about it, but this is a problem in general. So if you are working in AI, if you are not just an influencer, but if you are actually working in AI space, you would know that data bias is a really painful thing that we encounter all the time. It's not like this is the first time, and since this is the Chinese company, this has come up for the first time. Data bias is something very crucial that for almost all the models available, it is kind of already there because most of these LLMs are obviously trained on data that are there in the internet, and internet has all kinds of data. You can't say like internet doesn't have all the data that you have is unbiased and the volume that these models work with. So the volumes of data that all these LLMs are trained on, they are so large that it is very difficult to make it unbiased. So there are ways or metrics to kind of evaluate the biasness of a model, but again, again a gray area, and this is not the problem of this model alone, this model family alone. This is something that is shared by almost all the LLMs in some way or the other. Obviously, if it is a Chinese model or a model basically built by a group of Chinese scientists, you would get to see one kind of bias. Whereas if you are using a model which was built by Western media, sorry, not media, but US or this Western law, you would again see some kind of bias, some other kind of bias in the data, which a lot of people have raised a lot of question in a lot of time. So again, uh, hopefully, I have tried to explain a lot of things. This is a big video. But if you have listened to this entirely, hopefully you gain some technical understanding of how these models are slightly different